going to hit record, and then we'll just go back to reshare. So I'm recording it now. I wasn't recording it since I was seeing both of you, but if it's helpful, then I will go ahead and start doing that. Okay, so
I mean, also since we can't like stop by at lunch and be like, hey, I have a couple questions.
Absolutely.
And being able to look back at the lecture and review it is really helpful for us, and probably even for your in-person students.
Yes. No, we're good. So yeah, I will do that. There's a little bit of a process that it takes. So once I finish the lesson, it'll take probably a solid hour before I can get it up online, because it has to be rendered, then it has to go over to YouTube. It has to go through YouTube's process to generate an ID, and then I kick it over to Classroom, okay?
Sounds great.
So I'll do that. Okay, so guys, notice I factored it for you. So does anything jump out at you about -1 itself? It doesn't exist, right? So now the thing is, as long as we talk about it this way, I could say that that is the same as this, as long as I say, hey, by the way, don't pick -1 itself. There's going to be a problem that exists right there. So what happens is I get really close to -1. What does the numerator get infinitely close to? It looks like as I get close to -1, the top is getting close to the number 2, isn't it? What's the bottom getting close to? So it's getting close to -2 and -5. What do you think that is? It's 2/5. Now, did anybody actually plug that in and actually try numbers that were getting really, really close to -1? I was hoping that you would. Did you? Because I would like you to actually get into the habit of being able to do that. I was actually hoping you would say x squared plus 4x plus 3, x squared minus 3x minus 4. That was weird. I think there's a helicopter that just went over the top because I just felt the buffeting. Okay, so I want, oh, hey, what's a number I could use for this that's -1 with a minus? Like negative, what's that? I want to get really close to -1 from the left side. I heard somebody say -1.1 or -1.01. But you guys see what number that appears to be getting closer and closer to the, oops. What happened? It didn't like that. Oh, I missed the 1, that's why. I mean, do you see, does it appear to be getting really, really, really close to that number of -2/5? But then if I look at it from the other side, what would I plug in? What's the number to the right of -1? Yeah, like something like -0.99. Or 0.999. I mean, you don't need to do very many, but you can still see that that number is getting extremely close to -2/5. But can you say this right here? Is the limit from the left the same as the limit from the right? Or do those two things both exist? That answer is an absolute yes, affirmative answer. So it is kind of important. It's funny to me. Do you guys know how, like, did your English teachers ever tell you not to use the word very? It's like, this is very important. Does the word important already communicate it? This guy likes hugely important. Does that do it? He says that in his notes frequently, but anyway, it is a point of real significance, is that when we start talking about continuity, and I think you guys have a general, just innate understanding of what it means to be continuous, right? What was wrong with that problem that we had a moment ago? Was it continuous? There was a little bit of a hole there, right? We had an issue. There was something that broke it. So see his analogy, road in, road out, but it better be equal to that bridge that actually covers that there's nothing wrong in that middle. So this, what you're looking at right here, this is actually the definition of continuity. It's a definition. So if they ever on a test say, is this continuous? Your definition says, is the road in the same as the road out? Is it the same as the bridge? And you would have to be able to do that. And so when you're looking at this next one, using that definition, what's the first thing that we would want to do? Let's factor that sucker. Oh, goodness. Let's see. That's a plus 10 and a minus 2, which leaves us an x plus 2x minus 2, an x plus 10, and an x minus 2. Okay. So is this graph continuous at x equals 2?
No.
No. What's wrong?
There's a removable discontinuity.
Because x equals 2. Now going back in here, what is the problem? Because what I could say is that the limit as x approaches 2 on h of x is not the same as h of 2. Notice that? So I would say it is discontinuous. How about at x equals 0? What do you guys think about at 0? Is that one okay? Yeah, because in fact, the limit as x approaches 0 from the left of h of x is 0. The limit as x approaches 0 from the right of h of x is 0. And in fact, h of 0 is 0. And in fact, it's kind of a funny thing to do, and this is considered in calculus speak an okay thing. See, what do I have right here is I have the 3 components of my definition, don't I? I've got the 3 definitions right there, and is 0 from this one the same as 0 from that one is in turn, it's not like 4 equals 4 equals 4. It's just, it's these 3 values that I got from analyzing bridge in, bridge out, and the bridge itself. Do they all fit? So does it actually satisfy the equation? Yeah, but how about right here? So let's try that. What is the limit as x approaches -10? And what is the limit as x approaches -10 from the right? Can you guys go find that out? What is that value? So what would be an easy way for you to decide what those values are? So what might you plug in from the left? Is -10.001. From the right, what would you do? -999. Try it. What do you get off of your machine if you try those numbers immediately to the 2 sides?
Positive and negative infinity, respectively.
Yeah, it looks like when I approached it from the left side of -10, I got a big stinking number, right? What did we know from last year? What should this look like if I was actually looking at the graph? I've got sort of a vertical asymptote. So this particular one is going to -infinity, and this one is positive infinity. So what I could say is the limit as x goes to -10 is not equal to the limit as x goes to -10, so discontinuous. Now this is actually, I told you calculus is one of those things that almost has a philosophical, have you ever done that in your like history class where you're trying to prove a point and you lay out all of your argumentations and then your conclusion is, this was actually not the cause of the war because of the points that I laid out. Don't you have to kind of confirm it and actually say that you've actually established the whole thing? See, where am I getting this statement from here right here? See that? I'm actually pulling directly off of the definition. It says, I tested it and it doesn't match what the definition requires. Are you guys okay with there? Okay, now that's sort of an algebraic perspective. So now sometimes we have these kind of problems. Last year we studied this. Todd, I'm so sorry. I'm going to keep referring to last year, but this is called, what did we call this kind of a problem? That was called a piecewise defined function where you're stitching together a couple of curves. So what is f of 2, everybody? Can you look at it? I mean, I look at this and I'm like, well, shoot. This says use the top one for under 2, use the top one for over 2. Oh, shoot, no solution. We don't have anything. But how about if I approach from the left of 2? What are we getting super close to? In fact, this is so lame, it's so easy. When I think of limits, I think of the little kid where they say, don't touch your sister. I think I said that last year because it's just a great visual. So what does the obnoxious little brother do if they say, do not touch your sister? They get super duper close, like the finger is like a nanometer from her forehead, and so she wants to pound the snot out of the little turd, but he's not disobeying because he's not touching, right? He gets super duper close. But you know what we do in calculus most of the time? I just jab her in the forehead and say, what happened? Oh, I got in trouble. See, if I plug in 2 from the left, just plug in 2. What do you get?
4.
Did it hurt? No, and I could go plug in 1.99999, but I think you all know I'm going to get 4. So in other words, just do it anyway. See what happens. You might get burned. I don't know, whatever. How about if we come from the high side?
3.
Oh, wait a minute. What does that mean?
It jumps.
So what's the answer to this question? Now, you're going to see that very frequently in a calculus class. DNE, which stands for does not exist. Yes. Oh, because if we come from the high side of 2, this is the equation that says come to the high side of 2. And 2 times 2 minus 1. Now keep in mind, I'm touching my sister in the forehead, just going, what happens if I do it? 2 times 2, I'm not going to literally plug in 2.0001. I'm just going to go ahead and plug it in and see what happens. Is it continuous here? What do you say?
No.
Not continuous. And see, the part that is a little bit tricky, and this is where I screwed that up. There's too many U's in continuous. That feels awkward. Anyway, so when you put all that in, what happens on the AP test, I can tell you some people get flicked and they lose points because they say it's not continuous. And they're like, I'm sorry. What's missing?
Gotta justify
Justification. Not continuous since the limit as x approaches 2 from the left side of f of x is not the same as the limit as x approaches 2 from the right side of f of x. Or you could, in a sense, because we have established this information up top, because 4 and 3 are in fact not the same number. This guy's right here is an extraordinary, you guys ever seen this picture before? This is a super, super famous picture. What I don't know is I'd love to know, in all honesty, is this an optical illusion because they're taking it at a strange angle and it actually was okay? Because what does it look like? It looks like somebody got fired like really, really, really bad, because that's a multi-million-dollar error if the bridge is that far out. So this is kind of what we just had in that story. So, okay, so can you guys go ahead and do this one right here for me? Using that definition of continuity at a point, can you tell me about the continuity of this function? Now, guys, before we ever start, what is the only places you would be concerned about its continuity? At 2 and -2, do you have to discuss whether it's continuous at -7? No, because you have studied what is x plus 2. It's a simple line, nothing is wrong with it. It in and of itself would be a continuous function. How about x squared over 2?
There's no way
Simple
you can
parabola,
get
life is good. You don't need to harass that and prove that that by itself is a continuous function. The only place you need to worry about is what happens at those two. So can you go find that information for me and tell me, is this a continuous function specifically at -2 and +2, and use proper notation? Hello, Janet. I have them, yes. Yeah, you didn't make copies for me. You sent me an electronic version, and I turned those into hard copies. I did. No, I went and made my own because I know you got a lot on your plate too. I think the reason why that we went digital, I know why now. Every single digital copy that goes has to get emailed to Mr. Hassey, who has to respond to it. So he would be getting several hundred of them. And honestly, he doesn't respond to independent emails. So there's just no way. Kids would be dropped. Kids would get dropped because they would never get his signature. Okay. We'd have to run it somehow through Renee, and she'd have to have authorization to do that because she would do it. But Rich just has too much on his plate to deal with that. But he has 300 plus students, so he can't do it either. Okay, so we're hard copy for now.
Amber, who's behind you?
Yep, that's what I did. Yep, got it. Thanks. Bye. Okay, so are you guys okay? I screwed that up for a second. So what do you guys say? What would you say is you'd say discontinuous where? At x equals -2. Why is it discontinuous, everybody?
There's a jump.
because the limit as x grows from -2 from the left of f of x is not the same as, well, I'm just going to write it that way because that's easier. Is it true that if I try to approach from the left, it's not the same as what I actually plug in if I do it? Or I mean, it fails multiple ways. We just have to list one of them. How about at 2? Okay, and it is continuous at 2. And again, the reason why, because I suppose we could just be cheap and easy, and we could say because I tested it and 2 = 2 = 2, or we could say the limit from the left is the limit from the right is the same. Now, this is the first problem that we get to that makes me smile. I love this question. This is 100% an AP question. So what should this thing right here be the graph of? What is ax² minus b? That's a little parabola, isn't it? So I've got a parabola, but what do I not know about it? I don't know how curved it is, do I? I also don't know how much it got moved up and down, what b is. And then I got this horizontal line. Now this is super bizarre. So it's a curve that hits a horizontal line. And then what does that become?
A line.
Oh man. So a curve to a horizontal line to a line, and what I want to know is I would like that thing to be continuous, and I need to find out what that is. So here's the deal. If it is continuous, everybody, what is f of -1?
4.
So that would tell me that the limit as x goes from -1 of f of x must be what? And the limit as x goes to -1, I could go left, I could go right. No matter what I do, those numbers have to be the number 4. So look at the top one. What happens is I get super, super close to -1 on top. What would I get if I got close? Remember, I said I just go ahead and poke my sister in the forehead and I call it good. As I get close to -1, what am I going to get? A minus b, and we just found out that a minus b, what must that be equal to? It has to be equal to that guy. But what happens if I get really super close to a on this one? What should that be? I'm getting really close to -1 right here. That would be -2a plus b, and that should also be 4, shouldn't it?
Set them equal to each other.
Oh! Since they're both equal to 4, we could either set them equal to each other or we could just add down. What does a have to be?
-8.
If a is in fact -8, that would satisfy the equation. And what would that make b?
-16.
Let's add 8 to both sides. What's b?
12, because I just
Oh,
can't do math.
-12. So see, if we found a to be -8 and b to be -12, that kind of forces those things to stitch each other together and kind of finishes our story. Now I'm going to skip up a little bit. I'm going to go all the way to number 11. We're going to run out of time, so I want to be a little bit careful. So there's some places we're going to be a little bit more cavalier here. So last, do you guys have that? You all right? So here's the thing. If you remember last year, we talked a lot about the shape of the Big 12 functions, didn't we? So what I want to do is I want to also just know what we know. You guys probably know what ln x looks like, because it looks sort of like this, right? You should know that 1 over x. What is 1 over x? The reciprocal function looks like. The reciprocal function 1 over x looks like this. But somebody replaced x with x minus 3, didn't they? And that should kick the graph to the right 3 units. Remember graphing by transformation that we did a million times. 1 over x squared is going to be a graph that has been kicked to the left 2 units. These are all graphs that we studied last year. The secant was the reciprocal of the cosine, wasn't it? So it might be helpful to draw the cosine in here. Oh, shoot. What happens if I take the reciprocal of this cosine wave? Hopefully you guys remember that puts an asymptote right here in the middle. Now, why is there an asymptote right there? At x equals pi over 2. Why is there an asymptote? Is because that's where the cosine itself was 0 and it got flipped over, right? See if you remember. What's the reciprocal of 1? 1. But as that gets smaller and smaller and smaller and closer to 0, what happens to its reciprocal?
Exponentially larger.
It gets huge. It goes this way, boom. And this one goes this way, boom. The green is supposed to be the actual secant. So now let's see if we can answer those questions. What is h of 0? You tell me. Now that, see again, if I know my analysis, the calculus is easy. What happens if I try to plug in 0? What does it say? Doesn't exist. Can't do it, right? No solution. D and E does not exist. How about if I try to get close to 0 from the left-hand side? No, doesn't exist again. Why not? There's not even a defined out there. There's nothing there to be defined. How about 0 from the right side? Now, this is a funny little thing. Welcome to calculus. This is a funny little thing. Would it be okay for me to say negative infinity? Isn't that where it's going? Could I say this? Because if you're saying there's a limit, you're literally saying there's a place that I'm trying to approach and there's something that's there, okay? So here's the deal. This is the answer we almost universally want you to give. Why? Which is more instructive?
Yeah, the negative infinity.
It tells you what the graph is doing. What could this be? What does D and E mean?
Does not exist.
It might be a hole. What else could it be? A jump. It could be just a place where the graph doesn't exist. There's a whole bunch of things. This is actually saying, oh, there's a graph there, but it's plummeting. So what's the answer to this one right here?
Does not exist.
That one is 100% does not exist. Can you fill out these here for me? Numbers 2, 3, and 4. Again, hopefully the picture right here helped you be able to understand what's going on there.
On example 9,
Yep.
the one that we just did,
Yep.
if we added down the a minus b, where did you get the negative 2a plus b from?
Oh, because what I did is if I plugged in -1 for x, 2 times a times -1 would be -2a.
All right. We're good.
So,
I got you.
So it's that whole thing. Sometimes when you're doing a limit, you just go ahead and plug in the actual number that is there. So this one was, from the left, was negative infinity, positive infinity, D and E, positive, positive. All right. And doing my best to not be overly encyclopedic because I would like you to have a few minutes. You guys all right? Did I go too fast? Okay, just a little quick picture, okay? You guys have seen problems like this with you before, yeah. Which one? Oh, that stands for secant, which is 1 over the cosine. A secant of x is the cosine of x reciprocal. So what we use, again, so you realize that we use, let's see if you guys remember this. What was sine over cosine? Olivia asked what SEC was. Sine over cosine is tangent, right? Okay. We could say that cosine over sine, what was that one? That was cotangent. 1 over the cosine is the secant. And by the way, 1 over the secant is, well, the cosine. And what's the last one? 1 over the sine of x is the cosecant of x. Or 1 over the cosecant of x is the sine of x. So what do you call it? Absolutely. You may absolutely have this. What do you call that? 1 over the cosine. Oh, okay. So just, there you go. By the way, Olivia has already taken the class that you're in, so she's been through all of this, but you know, in different cultures, they just do things in a slightly different way. Did they call your class maths?
No, we call it like science-related math. So it's just called like by letters. So it's called like R1 and R2. So this class would be like R1, and I'm supposed to be R2. Which would be
Okay, so like if you're doing algebra and you had,
you just have like 3 different math, like the R1 is the most difficult one, which is more direct science, like health.
okay,
And then we have like the S math, which is more like social studies math, like economics.
oh, okay,
And more like
oh.
and then we have like
So they're actually honoring the fact that math is pretty usable. That's cool. So in Norway, they have a letter that says like, you know, maybe you had E, which stands for economics, E1, E2, E3. And so it's different levels of math that would be usable in an economics standpoint, or calculus being a scientifically useful thing. They call it S math. So anyway, you sometimes, this is going to end my day right here, is that there are often we have a situation where we have a mathematical model in the form of a picture where we don't have an equation. There is no equation for me to analyze. It's just making sure that we do that. We have looked at this in the past, but this is a pretty typical thing. So what do you guys think about this answer right here? The limit as x approaches -2. Now this is extremely picky and you have to learn to be picky. What is missing in this problem? There's no directionality, right? So what am I asking you implied by the way it is phrased? Both sides. So if I find -2, what are we seeing is that both sides of this appear to be going to infinity. Would DNE be an acceptable answer?
Yes.
Technically it would be, but this is a better answer because it's more informative. How about the limit as x goes to the number +2, but what do you notice here? So if I got really close to the number +2 from the left side, what does it appear to be getting close to?
5.
It looks like it's getting close to 5. Now, please understand something. Is it getting close to it? Now, this says don't touch it. Just get close. How about f of 4 itself? 1, 2, 3, 4.
Also 5.
Oh, that's 5. How about the limit as I try to get close to 4? Now, wait a minute. It says the limit. That means I want to approach it from both sides. So if I get close to this from both sides, what do you guys see?
It's 5.
Oh, it's fine. There's nothing wrong. See, it was a continuous thing. I don't have to worry about that in those regions. How about here? This says let's get close to 11, but
From the right side.
from the right side. So here we are. Here's 11. We're coming at 11 from the right side. It looks like, well,
Also 5.
I guess we're 5 happy here. 5 from the left side looks like it's getting close to Nope, careful. Uh-oh, 5 from the left side looks like it's going up to infinity, doesn't it? What can I do for you?
Yeah, you have your mask, your thermometer, and
Yeah.
your gloves. You can just tell me. Right?
Yeah, I got everything.
Okay.
Is that whose phone is that you? Oh, we got the little Enter Sandman going on.
Yeah.
Yeah, I got everything.
Sign it there. I know it's disruptive.
Okay, gotcha. All right. Is that pretty easy, everybody? Like reading that information right off the graph? Okay, so let's just, I guess, finish. F of 2 was 4. Limit as x goes to 6 from the right-hand side looks like it was also 4. 6 from the left side looks like it was 2.
From the right side, 6 from the right side looks like 3.
6 from the right side here. That's
From
1,
the-
2. Looks like 2 to me.
From the
8.
right side
From the right side. Oh,
looks like 3.
you're
not
right. It is
4.
3. Thank you. Yeah, 3. I like it. 8, 6, 7, 8. That's this dude right here. The limit definitely gets close to 3 from both sides. F of -2
Does not exist.
does not exist. The limit as I go to 0 from the left looks like
2.
we get really, really, really close to the number 2. And I think that finishes us up. So I'm going to go ahead and I'm going to ask people to work through a little homework thing on that. We'll have a few minutes. So people at home, this is going to be just, it says worksheet 1.1, limits and continuity. Should be pretty straightforward, and I think we're going to be good. I'm going to go ahead and stop.